This lesson is going to be on Hess's law, and Hess's law is going to be a different way that we can calculate delta H, or change in enthalpy. First of all, we need to understand that enthalpy is not dependent on the reaction pathway. And so what we are going to be able to do is, if we can find a combination of chemical equations that add up to give you the overall desired equation, then you can also sum their delta H's for the individual reactions to get the overall delta H for reaction. Okay, so it's going to be a little bit like solving a puzzle. It's going to seem kind of confusing at first, but I think they're fun, but you know, I'm weird. So, all right, a couple of rules about when we're doing the Hess's law. First is we have to decide how we are going to rearrange the individual equations so that the reactants and products are on the right side of the arrow, okay? And so some equations we may have to reverse and some will leave the same. If we do have to reverse an equation, because remember, most equations or most reactions are reversible, but if we do have to reverse one, we have to change the sign of delta H. So in other words, if the forward reaction is the positive delta H, the reverse reaction would be a negative delta H. Also, if we have to take the equation and multiply or divide, for that matter, to get the overall numbers that we need, we have to do the same thing to delta H. So basically, whatever we do to the equation, we have to do the same thing to delta H. So let's try a couple of examples and see if you can understand what we're doing. Okay, first one is exercise 1, and for some reason in your notes, it's actually reversed. Exercise 1 and 2 got flip-flopped for some reason when they printed out. I don't know why. But we're going to start with a very simple one, which is actually your exercise 2. So you might want to flip over the page real quick. Okay? So what we're going to be looking for is ultimately we want this as our final equation. Okay? So what we need to do is we need to look at, we're going to call this equation 1 and equation 2, and we need to rearrange them in a way that they would add up to what we're looking for. All right? And so, because remember, if something is on opposite sides of the equation, when we add them up, they're going to cancel each other out. Okay? So we need graphite on the reactant side, and if we look at this first equation, it remains this, graphite's where we need to be. So this one's going to stay the same. So this equation will stay the same. And since we know it will stay the same, we're going to go ahead and rewrite it. We're going to do carbon, and I'm going to do G, so we don't have to write it all out. Okay, plus oxygen, whoops, yields CO2. Okay, and it's going to be important to notice your states of matter, especially if you're dealing with water, because we'll do that GR, gas. Because water, the delta H is different for water steam, water liquid, and water solid. So you need to pay attention to that. Delta H remain the same. So we're going to say negative 394. I'll add my units later because I can't. I'm running out of room. But if we look at this equation, diamond is on the reactant side, and we need diamond on the product side. So we are going to reverse this equation. And so when we reverse it, we're going to write it as CO2 gas yields carbon diamond plus oxygen gas. And then because we reversed it, we have to change the sign. So we're going to make this a positive 396. Okay? Now we will add those two up. And when we do, we're going to look at what would cancel out. Okay? So oxygen is on the reactant side here. It's on the product side here. So oxygen is going to cancel out. Carbon dioxide is on the product side in the first equation and the reactant side in the second equation. So they will cancel out because they're going to cancel each other out. So what we are left with is carbon, graphite, yields carbon, diamond. And so it matches what we needed it to. So now we add up our delta H values, and we see that the overall delta H for this would be delta H is equal to 2 kilojoules per mole. Okay? And of course it's positive, so that means it's endothermic. All right, let's do example 2, which is your example 1 now. All right, so let's go to the one. Sorry about that. So this time we're looking for this overall reaction right here. Okay, and so we are going to look at our 2 equations. We'll call this 1 and 2 again, and we're going to look and see what needs to happen. Okay, so I always just look at the first one, and I see that NO is right here on the product side, and if I look up here, it's on the reactant side. So I see that I'm going to need to reverse that equation. So we're going to reverse that equation. So let's go ahead and do that and rewrite it. NO yields half of an N2 plus half an oxygen. And then that means I'm going to need to change my sign, because it's positive, to a negative 90.29. Now let's look at the next equation. Okay, so I've got half of a nitrogen, an oxygen, and then NO2. Okay, so actually if I look at that, I see that I don't actually need to do anything to it, because I've got NO2 where I need it, and I've got one whole oxygen, and so when I cancel that out with this oxygen and the other one right here, when I cancel those, I'll be left with a half, which is what I need. So I have to do nothing to that one. So I'm just going to leave it the same. So it's going to be half N2 plus O2 yields NO2. Okay? And then since I did nothing to that, I'm going to keep delta H the same. And then I'm going to add and cancel. So I see that I have half of a nitrogen on both sides, so they cancel out. I have half here, which is going to cancel out and make this one become a half. So that my overall equation now is NO gas plus half an oxygen molecule gas yields NO2 gas. So it adds up to what I need it to do. So then when I add my delta H's, my final delta H would be a negative 57.1 kilojoules per mole. And that's delta H of reaction, so I need to write that. All right, let's do one more before we stop. So in this one, we're going to be looking for this. So I always say circle it so you know what you're looking for. Okay? So I can see that on the first one, first equation, we'll call this 1, 2, and 3. On the first equation, I've got 1 carbon, and I'm going to need 5 because I have 5 right there. So I'm going to multiply, other than that it can stay the same, so I'm going to multiply the whole thing by 5. So when I rewrite that, I'm going to have 5 carbon plus 5 oxygen yields 5 CO2. And I'm going to need to multiply my delta H. The sign stays the same because I didn't reverse it, but I need to multiply that by 5. So I'm going to do that right here, 5. And I'm going to go ahead and leave it like this so you can see what we did before we added up. Otherwise, you might wonder where we got that big number. Okay? And so then I look at my next equation, and I have hydrogen on the reactant side. And so I have hydrogen here, so I'm going to need hydrogen to stay where it's at. So I'm not going to need to reverse it, but I need 6 hydrogen. And I only have 1, and I quickly go look at the other equations and make sure there's not going to be some hydrogen I can get somewhere else. So I know that I'm going to need to multiply number 2 by 6. Okay, so now it's 6 hydrogen plus, when I do 6 times a half, I get 3 oxygen, and that's going to go to 6 water. Okay, same thing, I need to multiply delta H by 6, but I do not change the sign because I don't need to reverse it. All right, and then I look at my third equation, and I see that the C5H12, which is pentane, is in the wrong place. I need it on the product side, and so this one needs to be reversed, okay? And if I kind of glance ahead, I see that I've got 6 H2O, I've got 5 CO2, and I've got 8 oxygen. And if I glance and look at my other ones the way I've rearranged it, I'm not going to need to multiply by any kind of integer or divide by any kind of integer. I just need to reverse it. So I'm going to reverse that. So now it's going to have 5 CO2 plus 6 H2O yields C5H12 plus 8 oxygen. And so for that delta H, I need to reverse the sign, because I reversed, so I'm going to say positive 35, 36.6. All right, let's add everything up and see what cancels. So I see that I have 5 CO2s right here, here, and here on opposite sides, so they're going to cancel. And here I have 8 total oxygen, and I have 8 total oxygen there. So all my oxygen is going to balance out. So I'm going to be left with 5 carbon plus, which is solid, plus 6 H2, which is a gas, and that's going to yield C5H12, which is also a gas. And of course, if I look at that, it is balanced. Got the same amount of carbon and hydrogen on both sides. So now I need to go add up all my delta H values, remembering to multiply the first 2 by the integers that they need. And when all is said and done, I get a negative 146.4 kilojoules per mole. And of course, because it's negative, that would definitely be an exothermic reaction. Okay? If you found this a little confusing, you might want to read in the textbook about Hess's law and see how you do that, or just practice them. You will have a worksheet on it. Also, remember, Miss Lawrence is available for tutorials while I am out. All right, that's the end of this lesson.